but it's a circular plot, 35 meters radius, diameter more or less, which is about 900 square meters.
And you have 3 plots, you said?
We have 3 sites, and each site has a control and a treatment plot, so 6 plots total.
Okay.
Yeah.
Diego, this is his work.
I'm Diego Dierick. I graduated in Göttingen University, Germany, and now I'm as a postdoc at Florida International University, and we are running a project here in Costa Rica looking at the influence of environmental drivers, in particular water availability, and how it affects tree growth. So that is the work you'll see all around here. You'll see one plot here, which is one of the treatment plots where we put additional water in the dry season and then see what the effect is of that.
Okay. What was your favorite hobby as a kid? Like, how do you think you got here?
I looked a lot for bugs. Went around with a little fishing net in the pools.
Where were you raised?
In Belgium, yeah.
Mm-hmm.
Yeah.
What part specifically?
The Flemish part around Ghent.
Okay.
I took a degree in bioengineering, and that I did in Ghent University, and there I finished around 2003. Mm-hmm. And then I started in 2005, I started a PhD program in Germany. And there I was in the forestry faculty.
Okay.
So in the end, what is for me very interesting within this project, for example, is that it allows me to combine my technical interests with my interest for nature. So a lot of what we run here is measurement equipment, and that needs, well, a little bit of a technical background. It's very helpful there. Central part for the experiment are actually the dendrometers, like you see them there. And we have about 20 to 30 in each of the plots. And they will tell us from month to month how a tree is performing, how the tree is growing. And another part which is quite important, that is, you see the blue mesh there, that is a litter trap. Basically you have an area of 1/4 square meter, and we collect that one will catch all the leaves that come down, and little branches, fruits, flowers, stuff like that. And that is collected every 2 weeks and split up into different fractions. And that gives us an idea, in particular the leaf fraction, that gives us an idea if leaves are shedding, if trees are shedding leaves, if there's enhanced leaf shedding in response to whatever environmental factor. So on a subset of the trees we have in each of the plots, and that is 10 trees per plot, we measure sap flows. So that gives us an idea how fast sap is moving upwards in the tree. And in the end, it tells us how the tree is responding to its environment. There's an idea about water consumption, and that should also tell us if a tree gets drought stress. We should be able to pick that up there.
So this is a bullet ant. They don't like to get their feet wet, so they walk on the cables. But they're also quite painful if you get bit by one.
Okay.
So here's the control plot. Diego's standing in there. Think about what is being controlled here and what is not. And that's to my students over there at St. Mark's. The other plot is down there. That's a little bit of a clue. And obviously, if this is a water project and we're adding water, what are we not going to do here?
So one could think to put the control and the treatment plot side by side to try and limit differences to the absolute minimum, but one has the danger that you're actually watering part of your control trees in that sense, because trees tend to root meters away from their trunk. And you could, therefore we want to maintain at least 20-30 meters of buffer in between the control and the tree.
Even, look, Diego has a used water bottle that he's using to keep his circuit, or his panel, I guess.
Yeah, it's a little circuit board. It's a voltage converter. And that one went into the bottle. It's safe there. So what we have here is battery to keep the system running. That keeps it running for a week or two. The data logger, which is the center, that one can control all the measurements, that determines, you can program it, set it up to control or to measure certain variables at certain intervals. And that one stores the data in the end. That is where you recover all the data. And the multiplexer, that one allows you to measure an awful amount of sensors. So we need to measure like 40 temperatures. And that one will allow you to measure all these different channels and guide them through your logger. And then a regulated power supply for the sensors.
The real-time data box. And it's collected actually on a little card, like a camera card. And they get it every 2 weeks?
We swap it every 2 weeks, yeah.
Yeah, and check their sensors and kind of make sure that the data looks like what they think it should look like.
Yep.
Based on trend.
Check on data quality in any case you want to do it.
Howler monkeys.